Swayam Prabha. Digital India. Educated India.
Question is in the board, write the answer. What we do, we have a cell. That cell is operated at 1 ampere current for 0.1 hour in electrolytic mode. What is electrolytic mode means? Non-spontaneous. That means concentration difference should increase. Correct? The difference in concentration in the left and right compartment should increase. Calculate after this episode. Calculate final concentration on either side of the cell. Concentration of the solution on either side of the cell. How will you do? What you have to do? First you have to find out. See, I have also given some more information there, 1 liter of electrolyte on either side, right? How will you do? Number of? These are steps. See, I have given you current and time that should transfer into charge. Charge is linked to the proton. So, I can calculate number of moles of proton disappeared in that time or appeared in that time. One side will disappear, one side will appear. Which side should disappear if in electrolytic mode? Left side should disappear, right side should appear. So, left side reaction will be reduction, correct no? Right side reaction will be now oxidation. That is the electrolytic mode for this cell, correct no? Just because your beaker you are changing, reactions will not change. But in the textbook we write it following an IPAC convention. So, I have not now followed any convention, I have given 2 half cell, but I have given you a hint that it should be in electrolytic mode. That means concentration difference should grow. How will you grow the concentration difference? Left side I should decrease further, right side I should increase further. So, if you look at that way, you will understand how the things change. So, 0.1 ampere into 0.1 hour is 0.1 ampere hour. If you look at this reaction, 1 mole of electron consumes 1 mole of proton. Okay. So, that means 1 mole of proton is equivalent to consuming 26.8 ampere hour, correct? So, now I have how many ampere hour passed? Because ampere hour is a charge, this is my charge I passed. So, that reaction might have happened. So, 0.1 ampere hour. What is this? Ampere hour cancel, how many moles you get? Calculate someone, 1 by 26.8 into 0.1 how much? You have a cell phone, I know. Take out cell phone. Calculate. 1 by 26.8 into 0.1 how much? Quick. What? Moles, right? This mole, so it's coming moles. Now this is 1 liter, 1 molar means 1 mole, and here concentration should decrease. That means this many moles of proton might be consumed. So 1 into 1 is 1 mole. In 1 mole you subtract this much mole. That is what present in 1 liter. So what is the concentration then? 1 mole minus 0.0031. How much is this number? 1 minus 0.0031. 37. Point. Huh? 963, yeah? This much moles, right? Now this much moles present in 1 liter. That means the concentration would have become 0.9963 molar, correct? Here it will increase, na? 2. This will be the end point. Clear? Understanding? See, here we have practiced also the Faraday's law without knowing. Correct, no? This Faraday's law, how much consumed, how much deposited, is a Faraday law. But we did not even use Faraday law explicitly. We simply went by whatever we know so far, we could do this. Correct? Clear? Now let us go some pre-made slide. You see here, I have taken here. So here I have taken lithium, 1 mole of lithium. 1 mole of lithium is 7 gram, correct? So if this is the reaction, half reaction, then 1 mole lithium oxidase will give 1 mole electron. That is the stoichiometry. So N is equal to 1. So I know the density of lithium. Okay, keep that in mind. And I know for lithium oxidation reaction, this is the potential. But what you see in your textbook is a standard reduction potential. That means a reverse. Go from here to here. Standard reduction potential, that is minus 3.04 with respect to SHE. Minus 3.04 with respect to SHE. So now this all we have done. Theoretical capacity can be written as 26 ampere hour per mole. Why? 1 mole of lithium can give 1 mole of electron. 1 mole of electron is 26.8 ampere hour. So 1 mole of lithium then will give this much only. And 1 mole of lithium is equal to this much gram. So this will come in the unit of milliampere hour per gram. So this is the capacity of lithium. Why it's called capacity? Lithium has a capacity of giving electron of this much from every gram. 3828 milliampere hour or 3.8 ampere hour. That much of charge lithium can deliver from each gram. That is why it's called capacity. What capacity it has so much capacity. Correct? And then you can also calculate the energy density. But to calculate the energy density, we need potential. We need potential. Let us put it this way. Suppose this is earth. I am dividing earth into 3 parts. And I put some material here, some stone or something. Assume air resistance is negligible. Assume air resistance is negligible. So I am dropping this from the rest. Take a stone, drop. Now, which way it will go? This way or this way? Down. It will go right, no? Correct? What do you think about its velocity? Will it be constant as it goes down? What will happen? Why it will increase? Gravity is pulling, why should it increase? There is some law. Which law in physics? Newton's law. What is Newton's first law says? That is Newton's first law. Okay, all the laws you tell me. Remains? An object will remain. If an object in rest will remain in rest, the object in rest will remain in rest until an unbalanced force acts on it. An article in motion will remain in motion until an unbalanced force acts on it. Suppose you go to space where there is no gravity, to that region you go. In a space where there is no gravity. That means there is no preferential direction for you to go because there is no driving force. In the space I am going to put you and I am going to push you. When I am pushing, I am giving some force. Now you will start moving, but there is no gravity there. So you will keep moving at constant velocity. How long you will move? You will move for your lifetime. You will be endlessly moving. When your movement will stop, when some other force comes and hit you. You will keep going like that. Some meteorite comes in between, suppose it hits, then it will change direction or speed or it will get destroyed. Until it will be moving. Suppose an object in rest, it will forever will be rest until some force act on it. Okay, that is what the Newton law says, correct no? Suppose a force is constantly acting on something, what will happen to it? That is what happens to this object which is under the influence of gravity of earth. That means earth is continuously applying force. When I just apply force and leave it, it will be keep moving at constant speed. Initially it will accelerate, then it will move constant speed. But if I am continuously applying force, then it will keep increasing its speed, velocity. So it is called acceleration. A species which changes its velocity from previous value to the next value is higher than the previous speed, suppose. That means it is accelerating. Okay. Since it is a, see, earth gravitational force is a non-contact force. You can't see that, but it is still acting on us. It is a non-contact, invisible force. So that force is acting on this object. Therefore, this object will start gaining velocity. That velocity will be keep increasing until it hits the ground. When it hits the ground, it will lose the energy to the ground. That means it will bounce. If it's a ball, it will bounce, do like this, then it die out. Correct? Now imagine. So what will be the velocity here? Imagine earth is suddenly becomes small, but the gravity remains the same, somewhat. Okay. Then what will be the speed at this point? What will be the speed at this point? Imagine the mass is same. Now the mass will be different depending upon the radius we choose. But I am asking you to assume that I keep changing the radius, but still the mass is same, so that the gravity remains same. Make an hypothetical assumption. Now at this point, will the velocity be same or different? Where it will be more? The smaller circle point, right? Be more there. Okay. So that means when the particle hits the ground here, where will be more damage to the particle? Here, because here it comes with a huge velocity. So velocity times its mass is the momentum. So momentum is nothing but energy, right? P squared by 2m is energy, right? So that means the particle here has more energy than here, same particle. Depending upon the depth we are considering, energy will change. So voltage is like that. When I say voltage of the battery, it depends on what is your anode and cathode. If you change your anode and cathode, voltage of the battery will change. It is equivalent to saying, suppose I keep one of the electrodes same, I am keep changing the other electrode. Depending upon the energy of the other, depending upon the potential of the other electrode, the cell voltage will change. Cell voltage is determined by the difference between these two potentials. This is a potential of one of your electrode, this is a potential of your other electrode. Depending upon which electrode you choose, the voltage difference or the potential difference, which is called voltage, will be different. Okay. In this case, I measured this value by connecting this lithium half cell to a hydrogen half cell. So with respect to hydrogen electrode, this is the potential. So the cell I am considering here is hydrogen lithium cell. Correct? No. So it depends. If your reference, because this is here also called as a reference electrode, depending upon the reference you choose, the voltage of this guy will be different. If I change this reference to some other reference electrode, say standard Calomel electrode or some other electrode, then value will change. But concept will not change. What you have done, instead of this, if you put a standard Calomel electrode, it means instead of taking this as a reference point, you have taken another point as a reference point. That's all it means. But the truth did not change. It's still the same. Okay. So therefore, for lithium hydrogen cell, this is the potential. So if I want to know what is the energy density of this cell, all I need to do, capacity you got here, multiply by the potential. Potential for this cell. How much is that? 3.04. So that tells you this much energy. So ampere into voltage, the current into voltage is watts. Watt is a power. Watts is joules per second. How much energy delivered every second is watts, joules per second. So milliampere hour will become milliwatt hour. So you can convert with appropriate conversion into watt hour per kg. Correct? So in 1 kg of lithium, you will get this much of energy. 11,637 watt hour of energy. Watt hour is energy. Why? Because watts is joules per second. You are multiplying by time unit again, then it be joules, right? Therefore, it's a watt hour is a unit of energy. Watts is a unit of power. Watt hour is unit of energy. So now, if you see this much energy, energy can come in this many units: ergs, joules, electron volt. In this case, we are using the unit of watt hour. Why watt hour comes? Because ampere into volt directly gives watts. Okay. So, watt hour per kg. Now, this much energy lithium will release provided if lithium is coupled to hydrogen electrode. If we couple to some other electrode, different amount of energy will be released from the same amount of lithium. Why? Because as I said, it all depends on your reference point. You change your reference point, the velocity of the particle is changing. Velocity changing means energy of the particle is changing. Similarly, the energy of the cell will change depending upon what is your other electrode. Whether you are combining hydrogen electrode to lithium or some other electrode, depending upon change. For example, if I have, say let us take two electrode, one is lithium plus lithium electrode whose potential is minus 3.04 volt with respect to standard hydrogen electrode. This is a reduction potential, okay, reduction potential. Suppose I have another redox couple, zinc 2 plus and zinc. This has got an energy of minus 0.76 volt with respect to standard hydrogen electrode. Clear, no? Now I am combining these two. If I combine these two, which will be my anode, which will be my cathode in a spontaneous process, in a galvanic mode. Suppose, forget about all the chemistry, two compounds I am mixing. How do you know which will oxidize, which one will reduce? What property you will look for? Loud, one person. Yeah, how do you know which one will lose electron, which one will gain electron? Depend on what? We all, I think they have fed you well, right? So loud, please. Huh? How do you know which one will oxidize, which one reduce? You have to look at the electronegativity. The one we have very high electronegativity compared to the other will like to receive the electron. One has got, because you are comparing two things, same property of the two things. Electronegativity, suppose you take electronegativity of two things. The one which has high electronegativity has more liking for electron. So he will receive the electron, the other person will give the electron. Suppose you look at in terms of electropositivity, the one who has higher electropositivity will like to give the electron out, therefore the other will receive. It's a very simple logic. Now in these two you have to find out which is more electronegative. Who will give easily electron out? Lithium? Lithium. Then that will be anode. Lithium will give the electron out, your zinc ion will receive, become zinc. Okay, so lithium goes to lithium plus electron, same time zinc 2 plus will take the electron, become zinc. 2 lithium is needed for every zinc, because lithium, zinc is 2 plus, lithium is single plus. That's all we know. Correct, no? Now your anode is lithium, cathode is E cell. How will you calculate? E cell equal to who was your cathode? Correct? How much is this value? Quick. Minus 0.76 plus 3.04. How much? The simple arithmetic, no? 2 point, right, no? So if I combine these two in standard condition, the voltage I will get is 2.38. Then if I want to do the same thing, but instead of lithium plus H plus H2, I want lithium plus zinc 2 plus zinc, then the energy will be same or different? Why? Because the factor you multiply is now this value. So, a lithium zinc cell will give less energy per gram of lithium compared to a lithium hydrogen cell. Because your hydrogen cell, okay, was here, hydrogen is something like here, your zinc is something like which is here, your lithium is something like which is here. So, the voltage for this is small, voltage for this is big, therefore, the energy released is big for that system. Correct, no? Makes sense? So, that is what you learn from this, and then we can do the same thing for magnesium. Magnesium, it is a 2 electron process. So, 1 mole of magnesium gives 2 moles of electron, that means 2 into 26.8 is the ampere hour from 1 mole of magnesium. Plus it is a 2 electron process, no? 1 mole of electron gives you this much, 2 moles of electron will give twice that amount of charge. Then divide by the atomic weight, that will come in the unit of ampere hour per gram. Multiply by the potential. Again, what is the cell here? The other electrode is hydrogen electrode. So, it is a magnesium 2 plus H plus H2. It is a magnesium hydrogen cell. This is the energy you will get. If someone asks you what is the energy density of magnesium battery, if you give an answer, 0 mark. Because magnesium battery means what is the other electrode? That fellow told only one electrode, magnesium. Are you coupling magnesium to hydrogen? Are you coupling magnesium to zinc? Are you coupling magnesium to copper electrode? What are you doing? That is not said in that question. If someone asks what is the energy density of magnesium cell, you give answer, 0 mark. Don't give answer, also 0 mark. Ask question, then you get mark. What is the question you are supposed to ask? What is the other electrode? You understand, no? Many of the time I go to the, sometimes the question set by some people outside, I find this kind of problems. Question itself will be ill defined, then what is the answer you are expecting? The question should be clear. Question itself is confusing, answer cannot be given. Correct, no? Clear? Right. Now, quickly, you know thermodynamics, this G is a Gibbs free energy and this can be expressed in terms of internal energy, temperature, entropy, P and V. This all defines the state of a system. If I want to know what is the Gibbs free energy of the system, this is the equation. So, that means this is influenced by all these fellows. So, I have done the partial derivative of all these. Now, imagine I am doing at constant temperature and pressure. If I do it at constant temperature and pressure, this term will disappear. But I use the first law of thermodynamics, which says du is amount of heat added and amount of work done, the sum of these two. So, I know from the second law of thermodynamics Q reversible is TdS. I substitute it and then I can cancel these two terms, correct? Now, I am left with only these terms. Pay attention, this is reversible work, this is PdV. According to first law, what is PV work? Minus PdV. So, this can be replaced with minus WPV, correct? So, this is a reversible work. Work means can be anything. It can be electrical work, mechanical work or any type of PV work. PV work means pressure volume work, okay, anything. But what I am doing from the total work, I am subtracting the PV work. PV work means there is a pressure volume change kind of thing, okay. Then what I get is a non-PV work, which is that work that I am getting or delta G I have is nothing but work. What is that work? That work is a non-PV work. What is that non-PV work for electrochemistry? Electrical work, correct, no? So, that is how delta G becomes minus NFE cell. Why E cell? is a potential. Potential how will you convert into energy? Remember, potential to energy you can go by multiplying with the capacity or charge. Capacity is nothing but charge, right? Milliampere hour per gram. Ampere hour is charge. So, NF, N is the stoichiometry in that equation, F is a Faraday constant multiplied by E cell, that is your non-PV work. So delta G is equal to minus NFE comes from there. It's not a new equation that you have to remember. It comes from the thermodynamic derivation, assuming your battery operates at constant temperature and pressure. The battery is not operating constant temperature and pressure, there will be some other work. Now, this is your electrochemical series that you might have seen in your textbook, right? You see here, lithium is here, silver is here. In this series, one which has the most negative potential, reduction potential, is electropositive element. One which has got the most positive potential is an electronegative ion, element. Okay, that means in this case, lithium will give electron easily, silver ion will take that electron, become this. So, between silver and lithium, which is more electropositive, lithium is electropositive. Therefore, lithium will oxidize, silver ion will reduce to silver. Now, you see this one is given arbitrarily 0 volt. Why it is given 0 volt? Is it 0 volt? No. We have given arbitrarily 0 for that. We wanted to use it as a reference. What is a reference? Let us look at it. If someone building a building on earth, what is the height of this building? That is a question. What is your answer? I tell you each floor is 10 meter height, okay, 10 feet height, each floor is 10 feet height. What is the height of the building? 40? Answer is wrong. Why answer is wrong? I have given already 4 floors only there. It is partially correct. You measured the height of the building from the foot of the building. But I want to measure the height of the building from here. So, the different, no? Answer. Again, question is not clear. What is your reference is not told. It is implicit. Generally, when you refer to a building, it means from the ground. It's nothing wrong in that answer. Scientifically, I would say it is not correct. Because I did not tell you what is my reference. How can you say? Did I tell you it is a sea level? Did I tell you it's a local ground level? Or did I tell you it's a core of the earth? I did not tell any of this. But you still assumed it's a local ground level from where you measure and then you said. But in fact, the building will have a foundation. No, that is part of the building. Then ideally speaking, you should have started from the foundation. So, it's a lot of confusion comes now. The moment you did not define. Correct, no? So, now we look at it. Same way, we need a reference. That reference is taken as 0. But that does not mean it has got 0 volt. So, how will you find out? We will do that. So, now if I take a lithium and couple with the potassium, I will still make a battery. Why? Between these two values, this is more negative. So, lithium is more electropositive than potassium. Correct, no? So, therefore, lithium will give electron, K plus ion will take it, become K. Whether it is happening or not is a different question. You remember why? Thermodynamics will only tell you whether the reaction happen or not. What it does not tell you, how fast the reaction will happen. Correct, no? There is a difference. If someone says, will this bus go to that place or not? I can look at the board and say yes. But the next question, how long it takes? I don't know, it depends on the driver, road condition. Correct, no? Thermodynamics is like that. It tell you it will happen. When? It will not give you the answer. Kinetics only will give you the answer. Okay. So, a reaction can be thermodynamically feasible. That means this bus will go to that town for sure. But kinetically may be slow. That means this bus may take 1 year, 2 years, 3 years to reach there. We don't know. Right, no? So, it is important your reaction thermodynamically feasible, also kinetically fast. Then only in real time you will see product forming. Otherwise, you have to wait for the product for ages, it may not form. That does not mean that reaction is not happening, it is happening very, very slow. Correct, no? So, in other words, in chemical kinetics, you might have studied something called activation energy. So, that is what I asked in the morning when I say rate, K times A we wrote, correct? I asked how will you expand K? You did not answer me. You will expand K like this. Correct? What is that? I assumed an Arrhenius kinetics. So there is a frequency factor times e power minus activation energy by RT times the concentration. That is the rate of the reaction. Imagine, anyone know how to plot e power x plot? E power x, sorry, e power x, this is x. How it will change? How it will change? E power 0 is how much? 1. So, if this is 0, what should be the value here in the y axis? After that, what is e power 1, e power 2, e power 3, e power 4, e power 10, e power 100? How the function will change? Correct, no? This is exponential function. Suppose you have a function like this. Let us not say c, we will take simple one. Y is equal to 4x. Now I am plotting. At x is equal to 0, y is? So this is 0, 0. So it starts here. X is equal to 1, y is? This is 4, this is 1. So point is here. X is equal to 2, y is? So this is 8, this is 2. So this will be a plot like this, straight line passing through origin. Correct, no? Simple mathematics you should know how it is changing. So now what you see, e power x, when x is increasing linearly, but e is not increasing linearly, e power x is not increasing linearly, it is going faster than x, right? Here as x increases, y goes in some fashion, but here when the x changes, y fast changes. You see from here to here, a very small change in x, right? But the y value change is huge, it is exponential function. For a small change in x, there is a huge change in y or e power x. Correct, no? That is exponential. Similarly, e power minus x, when the x is increasing, e power x minus x will, correct, no? Will become more so. So, if my activation energy is increasing, EA is increasing, e power minus EA will, so when the EA is very high, say infinity, e power minus infinity will become, so 0 into that rate is no rate, the reaction does not happen. This is what I am telling, kinetically something prevented means, thermodynamics is allowed, kinetically prevented means what? Thermodynamics says reaction will happen, only problem is activation energy is very high. So kinetics will say since activation energy is very high, reaction is happening but rather very slow. How slow it is? It can be as slow as possible. It may be like one molecule becoming a product in 1 million year. Very slow, no? 1 million year, one molecule becomes A, becomes B, one molecule, not 1 mole also, one molecule. Very, very slow. It all depends on activation energy. Okay. So that is what is important. You have to understand this activation energy concept very much. Okay. Now, if I combine lithium and potassium, it can form a battery. It will give a voltage. Open circuit voltage will come. What is open circuit voltage? Take this lithium electrode, potassium electrode, put it in the electrolyte, connect with the voltmeter. We will see some voltage. Just because you are seeing a voltage and that happens to be positive, E cell is positive means what? Delta G is negative. E cell positive means delta G is negative. Delta G negative means reaction is spontaneous. That means it is a galvanic cell. Just because thermodynamics says what you got is a galvanic cell, doesn't mean that cell will work. Why? Activation energy may be very high. Therefore, when you combine lithium and potassium, it may give voltage, but cell will not run. It means activation energy for the process is very high, therefore it did not run. We can make it run, there are ways to do it, but as such it did not run. Now let us take lithium and combine to magnesium, it will give better voltage than these two couple, right, higher voltage. Still reaction may not happen. I can take lithium coupled to zinc, I get better voltage, even better voltage, but may not run, depends on the condition. Similarly with hydrogen I can do, similarly with copper, iron, anything. So any two reactions here, off reactions here, can be coupled to make a battery in principle. Will battery work or not depends on the kinetics. If we have to influence the kinetics, what we do? The reaction is slow, what will you do to make it fast? Catalyst. So you put catalyst. We put catalyst, reaction will go fast. It will go fast to reach the equilibrium. Because any reaction A goes to B, not all the A will become B. After some amount of A become B, then B will become A. So the rate at which forward and backward reaction will be equal at that time. So at that time the concentration of A in the solution, concentration of B in the solution are called equilibrium concentrations. Definitely concentration of A at the time will be less than the initial concentration. Concentration of B will be definitely more than 0, but that will not change with the time once the equilibrium is reached. Once equilibrium is reached, it will not. It is like this. Suppose I have a beaker, another beaker. Here water is this much, here water is this much. Now imagine I am going to, these two are membrane, okay. Which side pressure is more? Left side, no? Right side. Where the pressure is more? So pressure I am measuring here. Where more pressure will be there? Big column or small column? Big column, right? Why? That much water is there whose weight is acting downward by the gravity. Therefore, if you go there and check the weight, that entire weight is acting on you, you will feel more pressure. Same gravity only doing this. Otherwise, this big water, weight will not be there. Why? Because there is no force. So nothing is pushing you, then you will not feel. Go to the space. Take this water on your head. Take 1000-liter tank water on your head. You will feel no difference. Why? Because there is no gravity, nothing is pulling that down. So it is not forcing on you. So you will not feel. You can pose as if I lifted one mountain and holding in my hand. You can act. Go under near a meteoroid and say, see, I am holding the meteoroid. No problem. Correct? No, because there is no gravity. You are not lifting. You are only giving photograph like that. You are posing like that. But in earth you ask you to do lift one big this stone. In one hand can you lift? Correct? No, it all where you are doing that matters. If someone asks me, can you lift a mountain? I will say yes if it is in space. Then I don't need to spend energy. I go under the mountain. I just say yes, I lifted. Correct? No, answer is correct. Na? I lifted. It's a mountain. But can you do it in earth? Okay. Otherwise is to ask like Sendil, no. I can lift, but someone should lift and put in my hand first. Then I can lift. That also not going to happen, right? Right? No. So now you see pressure more here, less here. Now these two are the permeable membranes. Okay. Bring them closer, attach. What will happen? Here pressure is low, here pressure is high. Then water will go from, here pressure is, at the same point here pressure is high, at the same point here pressure is low. So water will shift from here to here. Will all the water go there? Why? After some time equilibrium will reach. What is equilibrium here means? A level on both sides will become same. That's called equilibrium. What does it mean? Once you reach equilibrium, one water try to go this way, same time another water try to come this way. Both are equally probable. Therefore, there is no change in the level. How much ever time you wait? 1 hour, 10 days, 30 days, 40 days you wait, it still be there. If there is no evaporation, it still be there. Correct? No? Same in reaction. When A goes to B, once equilibrium is reached, You wait 100 years also, watch, it will be the same concentration because reaction reached equilibrium. There is no driving force to preferentially pull the reaction in one direction. Only when there is a driving force, you can. Here, what was the driving force earlier? There was a pressure difference. Therefore, liquid was going. After reaching same level, pressure here is same as here, pressure here same as here, pressure here same as here. Then where is the driving force? So they don't do anything. Same for the electrochemical reaction also. Right? No. So keep that in mind. Okay. So therefore, all these things as an equilibrium. Okay. Once you reach equilibrium, clear? Now, oh, it's working. So now you see, let's take, in the previous slide you saw some potential for each electrode in the electrolyte, right? How that potential develops. Now let us look at, we have a copper electrode, it has got a Fermi level. What is a Fermi level? It's a topmost level where you will find electron. In case of atom, it is a topmost atomic orbital where you find the electron. For example, lithium. Lithium, how many electrons per atom? Who is having 11? Sodium. So 1s2, 2s1. So half filled 2s orbital is a Fermi level for that. But with one atom we will not talk about Fermi level. The concept comes when there is a band theory, when many atoms forms a metallic bond and a sea of electron forms, right, in case of metal. So the topmost level is that means it will be a conduction band. The 2s band will become now a conduction band, that half of that is filled now. The topmost level is a Fermi level, right. Now that Fermi level, this is an energy axis, okay, this is an energy axis, and also this is a copper metal. So I take a copper metal and I am using this as an axis also, putting it in the solution. Now Fermi level is here. So the redox energy of the copper sulfate solution around this is here, okay. Copper sulfate solution, in that I dipped my copper electrode. So the energy level of copper is here, copper sulfate solution is here. Then what happened? There is a change in difference in energy, no? So whenever there is a difference in energy, energy will flow from one side to other side. But how the energy will flow? In this case, energy to flow, there has to be a mass transfer. Without mass transfer, energy cannot flow here. What do you mean by mass transfer? Suppose I am standing here, there is a fire. Will I run away or not? In space I am standing, at the same distance there is a fire. Will I run away or not? Why? Why? I won't run away. Heat needs a medium to transfer. Light doesn't need. You see fire because it gives also light. So in both the cases I see fire, but in one case I am afraid, one case I am not afraid. Because there is no medium between us. So how much ever it burns, that heat will not reach me. But if it is here, I see fire, I run this side. Right? No. Medium is important. Without medium, it will not happen. You see the context. Okay. Now what we were discussing, here energy higher here, lower here. I have to transfer the energy. For that I need a medium. Without medium, I cannot do this. That means medium means there is a mass. There is a air particle here, no? There is a mass. That only takes the energy, vibrate, comes to me and gives the energy to me. So therefore I feel hot. So now what will happen? This copper fellow will oxidize, now reduce. Copper 2 plus ion in the solution will now reduce. If copper 2 plus ion reduce to copper, how many electron it needs? Who will give that electron? The electron from here will come out, because that electron only has energy. It comes out, gives that energy to copper 2 plus. So therefore this metal side, because this is an interface, right? This solution, this is solid. So this is an interface. So from here electron came to here. So this will become positively charged because it lost electron. But here what happened? Copper 2 plus become copper 0. But copper 2 plus solution cannot be made. What solution we can make? Copper? You can't make only positive ion solution, negative ion solution. So it actually is a copper sulfate solution. Now copper is lost from the solution as copper metal, then your sulphate is left alone. Now it is negatively charged. So your solution side now will get negatively charged because of the counter ion. So now you see in the metal there is a positive charge, in the solution side there is a negative charge. So whenever there is a charge separation in a space, we call there is a development of potential. There is a development of potential, because the positive charge will now keep on attracting negative charge. Negative charge will now keep on attracting positive charge. Now you see, when I am saying attracting means it developed a force. Correct, no? When I say attract means what? I developed a force. Correct, no? That force was not there before. The moment I insert copper metal into copper sulphate solution, I generate a force. When there is a force, electron will flow, right? Earlier electron was simply sitting here as per the your what law? Newton's law. Simply sitting. There is no, so as inertia sits there. Now because of this force, electron is pulled. Therefore electron came out. So it's happening simultaneously. You cannot say which one happened first, egg or chicken, no. Okay. But because of this act, you got a charge separation. Okay. That charge separation, magnitude of the charge separation only gives you potential voltage for this interface. So every electrode electrolyte interface is unique. So there are different value of potential will develop. That's what there in the previous slide, electrochemical series. Now let us take another situation, a zinc metal dipped in a particular concentration of zinc sulphate solution. I assume that the Fermi level of zinc is here, redox energy of zinc sulphate solution is here. Who is having now higher energy? Zinc sulphate solution. So now here what will you do? Electron cannot go from here to here. If it goes, then what will happen? Energy will further reduce there, then that become like an electrolytic cell. We are changing the energy difference further. That is an electrolytic process. I want to do a galvanic process here. What will happen? Zinc will now oxidize, go into the solution, leave the electron back in the zinc. So when it leaves the electron back in the zinc, one of the unfilled orbital now will get filled by that electron. So energy level of zinc now will rise. So your zinc will become negatively charged, solution now will become positively charged. Why solution become positively charged? I introduce a zinc ion which does not have its pair in the solution. So now here negative charge, here positive charge, earlier here positive charge, here negative charge. So again, when there is a charge separation, there is a force and there is a potential developed. Okay. So now when the potential, if the potential be keep developing? No. When equilibrium reached, the potential development will stop. So when equilibrium will reach, when the energy level here, when the energy level here, both are equal, equilibrium will reach. Therefore, as soon as you insert copper into copper sulphate solution, initially there will be a reaction. Within few seconds it will stop. Why? Because a potential is established and system reached equilibrium. Similarly, when equilibrium reaches here, potential will develop and it will stop. The developed potential is what given in the previous slide. Clear? That is this potential. Is how potential develops. So now this energy level here, this energy level here are not the same, right? Because when I have not combined these two, if I combine these two, how it will be? Zinc is more electropositive than copper, right? That means this energy level must be higher compared to copper, because zinc is more electropositive than copper. Then this particular energy level which is in equilibrium, so this is zinc dipped in zinc sulphate solution, this is copper dipped in copper sulphate solution. If I want to combine these two, it will look like this. Zinc equilibrium with the zinc sulphate solution is here, this is energy axis, okay, and copper equilibrium with the copper sulphate solution is here. That means this line, no, I am plotting that line only, okay. So here it is negatively charged, here it is, okay, this is in equilibrium, this is in equilibrium, they are separate equilibrium, but cell is not in equilibrium. Why? Because this is zinc electrode dipped in zinc sulphate solution, Copper electrode dipped in copper sulfate solution, I put a salt bridge, correct? But cell is still not running, right? Cell still not running, it is open circuit cell. When it will run? When I connect a wire, then it will run. Now imagine if I connect a wire from here to here, which way energy will flow, electron will flow? From higher energy to lower energy. Who is having higher energy now? So what will happen? Zinc will further oxidize, electron will be added here, correct no? And this will reduce. So this energy, because the electron goes from here to there, no? So the energy level will be at some point, that is where cell is at equilibrium. Until that level comes, electron will be continuously flowing in the circuit. Correct no? Until that happens, electron will be continuous. That means cell will be until then working. At this point in time, the voltage here is same, right? Then E cell will be E cathode minus anode. Cathode potential, anode potential same. If E cell is 0, delta G, so cell is at equilibrium. You remember in thermodynamics says, if delta G is 0, the system is at delta G negative, spontaneous, delta G positive. So when I started this cell, delta G was negative. At equilibrium, delta G become 0. Now I wanted to make delta G greater than 0. How will I do that? I put a power source. The power source now will reduce zinc, oxidize copper. That is an uphill process. That is a non-spontaneous process. At that time, delta G will become automatically greater than 0. Your E cell will become negative, right? You can check, your E cell will become negative, right? No? So that time what will happen? You are taking back to the same level. You will go travel this flow this way, travel this flow this way, correct? Then you will go back to the original one. That's called charging of your battery. So discharging, charging. Correct, no? Makes sense? Any question? Now, how people have calculated the values in the electrochemical series? It was not done by electrochemist. It was done by thermochemist. How did they do without doing electrochemistry? Very interesting, no? How did they do? You might have studied Born-Haber cycle. Have you studied Born-Haber cycle? You might have studied without knowing why I study, correct? Yes or no? See, whenever you get such question, you should first clarify yourself why you study. If you study that way, you are really studying. If you are simply mugging up going for that, remember morning what the director told. Those who are not having clarity, those who don't know why you are doing, are the one who will never get job. And they are the one they will say, I have MD, PhD, this is so many degree, I am not getting job. But degree any Dam and Dick and Harry will get in this country. Who will not get degree, tell me? Go to any college in Tamil Nadu or India. Will they send you back without degree? You get degree. Yes or no? Is anybody failed in the school or college nowadays? They will say this is Samuga Needhi, Adu, Idu. Correct? No? All that fine. But if you are not studying, what is the point? We should have retention at each category. If you are not studying from the childhood onwards, you have to show. If you are not studying, you stay one more time in that class. Then only the kid will know. Then only kid will know how to take both loss and gain equally. Now you pass somebody, irrespective of their performance, up to PhD, and then after that they don't know how to face the real situation, commit suicide, and then you will say it's a depression. That's not correct. Why? Because you have not trained them from the childhood to face the problem. in the name of something, you brought that fellow up to there. And suddenly he is facing society. Their society, if you are not suitable, they will simply say, no job. Then that fellow depressed. So who is responsible for this? You understand what I am saying? If you are not understanding, then you will only lose. So now actually earlier we were telling at each time that you are good, you are not good, improve, not all that we were telling from the childhood. Now we are not telling those things. We are bringing you saying very good, very good, very good, very good. You said now on your own you take care. How possible? Not possible. People should realize. Every exam is easy provided you understand the subject. There is no need to worry about NEET exam, JEE exam. Why are you bothered? As long as you are clear with your concept, you should be able to write, no? Keep that in mind, then you can easily get job. Even if someone not giving job, you will create your job. Okay? So, you will only listen to educationalist. Don't listen to other people. They will ruin the life. Be careful. Right? So, now if you look at it, what we have done? Born-Haber cycle. You see here we are looking at this reaction. What is this reaction? I have H2 gas. I want to break the HH bond. If you want to break the bond, you need to send energy or you will gain energy. How? Spend energy or you will get energy? And energy. So, what I have done only order of magnitude calculation. So, I don't worry about entropy change and all those things. I worried about enthalpy change, things like that. Now, you see this needs 203.3 kilojoule per mole of H hydrogen. That means you take the energy required to break the bond and you divide that number by 2. So, each hydrogen gets that number. Now, you are taking that hydrogen atom, it is in the gas phase. Now, taking the hydrogen atom, putting in the liquid. So, it will be floating here and there. Now, this hydrogen atom, from this hydrogen atom, I am taking out one electron in the gas phase. Now, if you take out an electron from hydrogen atom in gas phase, how much is the energy required? This much kilojoule per mole. Okay, fine. Again, this energy is positive. Why positive? Because you are pulling the electron from the gravity of the nucleus, correct? Nucleus is holding that electron. Now you went and said, I am taking out the electron. For that you have to give energy, na? That means you are spending, so positive. Now what happens? You are dropping this, so because already liquid exists, so it will get solvated. Because this is an ion. Ion, when you drop it in a solvent, what will happen? There will be a solvent ion interaction. Ion dipole interaction we call it. If it is a solution, is a dipole. Like water, which is a dipole. So, ion dipole interaction, when something coming together, it is equivalent to forming a bond. Energy will be, you see, negative 1088. So, if I want to go from here to here, I can make it as a 3 episode. Going from here to here, here to here, here to here is equivalent to going from here to here. Correct or not? You add these 3 values, it is equivalent to going from here to here, but I want to go from here to here. That means I take the negative of that value. So, I add all the 3 and change the sign. That will tell you what is the energy involved in going from here to here. Clear? But these two are different. H plus in aqueous medium is different from H plus in gas. They are not same species. They are very different species. H plus in aqueous medium, H plus in gas phase, they are very different. They are not the same reaction. H plus plus electron giving H2. When you write like that in the interview, we fail you. Why? H plus plus electron gives H2. Doesn't make sense. Because you are not telling me whether H plus in gas phase or it's in liquid phase. So, state of the matter is important. Take water, pour in your leg. Anything happens? Take hot water, pour in your leg, what happened? Both are water, no? State of the matter is important. Take steam, do like this, what will happen? Correct, no? Why? Same water. That fellow state is different from liquid water. He has more energy than this guy. Therefore, that energy is given to you, so you feel it is burning. Same here, H plus in water is different from H plus in gas phase. So, you must indicate while writing the equation H plus electron gives H2, reaction wrong. Put the matter H plus in aqueous phase plus electron gives you H2. Is it in a liquid phase or it is in the solution phase or it is in the gas phase? You have to write. Without writing, simply write the equation, fail. To that extent, you have to be careful while writing. Simply you cannot write. Correct, no? Now you see, I added all those energy, I got 429. Negative of that is this way, correct? This is called standard reduction, right? If it is in standard condition, then this becomes a standard reduction potential when you go from here to here. So that value is minus 429. Then it is per mole. So I can convert kilojoule into electron volt because I know the conversion 1 electron volt is this much joule. I can convert into electron volt. Moles I will convert into per particle. 1 mole is Avogadro number. So divide by Avogadro number. So you will get energy involved per particle. Per particle means 1 H plus, not Avogadro number of H plus, right? This is minus 4.45 electron volt per particle. That means if you take H plus in aqueous solution and you throw an electron to it, H plus in aqueous solution, you throw an electron to it, when it catches, how much energy it will release? Correct? I can do the same calculation for lithium. I have done it here. Lithium metal to lithium atom, it is called what? Enthalpy of vaporization. Correct? Atom to ion, enthalpy of ionization. Ion to in the liquid, hydration, right, solvation, and then to metal, right. Now I want to find out this energy, I calculated, comes minus 1.3 electron. You see who is giving more energy? H plus in water gives you more energy when I throw electron, or lithium plus in water gives more energy when I throw electron? Who gives, which is more in this? The negative sign is only for the direction. Which is more here? That means hydrogen is more electronegative than lithium. That is why lithium gives less energy. If lithium would have been more electronegative, it would have picked the electron first. Now lithium is there, hydrogen is there, I throw electron, it goes to hydrogen. Why? Because that is more electronegative than lithium. So therefore it goes to proton, back to hydrogen. That is what we discussed a few minutes ago in the last lecture. Lithium, hydrogen cell, lithium will be anode, hydrogen electrode will be cathode. Correct, no? Same concept. Using the energy we are proving now. Clear? Now, what I have done? I have taken this in a number line. What is number line? You know, 0, 1, 2, 3. This side will be minus 1, minus 2, minus 3, minus 4. This is a number line. So, I have put it in number line. So, for hydrogen it is minus 4.5, more negative, down. Lithium is minus 1.3, more positive, up. So, 0 will be somewhere here, more positive value will be above. Now, I know delta G is equal to minus NFE. Correct, no? Delta G is equal to minus NFE. And also what I am going to do, I have taken 2 electrode here, both has some number. But looking at the number, I can tell you this is more electropositive than this, right. But I wanted to make it more attractive. What I am going to do? I want to make among these two one as reference. How will I make one as reference? I have to assign a value. What is the value I wanted to assign? Anything you can assign. You can even assign some 10, 20, 30, it's your wish. But I wanted to assign for a reference a value of 0. How will I make minus 4.5 into 0? Add 4.5. But if you are adding 4.5 to this, everything should be scaled in the same scale, right? So I am adding the same amount of value here also. If this happens to be 0, then that will be 3.2. You see the gap between these two is 3.2, right? Here also the gap between these two is 3.2 only. Only thing I shifted the values, but gap I kept constant, going up and down. Makes sense? Any doubt in this? Now delta G is equal to minus NFE. This is energy E. So instead of delta G, put this energy value. Calculate the E cell. Okay? It's a 1 electron process. So it becomes 0 volt. This is 3.2 volt. Correct? No? Why? Because this is in the unit of electron volt. So divided by Faraday is in the unit of coulombs. So you convert all the unit conversion you do. Finally, it will come in volts. Okay. Now you see what has happened automatically. This plus 3.2 become minus 3.2 because this relation is negative. But instead of electron volt, now it become volt. Why volt? Because now I am expressing in potential. Earlier it was expressed in energy. This is in the potential scale. And this is 0 volt, this is 3.2 volt. This is what I have given in the electrochemical series. So I can do this Born-Haber cycle for anything, zinc, copper, magnesium, and I build having hydrogen as a reference electrode, build electrochemical series. And that's how that series was built, not by electrochemist. It is just a electrochemical series is a outcome of your thermochemistry. It's not new. Clear? If you know Born-Haber cycle, how to construct, you know how to construct electrochemical series. Yes or no? Then why you are reading again electrochemistry separate subject? It's a problem, no? What it means? We have to restructure our curriculum. We can't teach in a compartmentalized fashion. Physics, chemistry, mathematics, that itself is wrong. And in the chemistry, organic chemistry, inorganic chemistry, physics is further wrong. The inorganic chemistry, main group chemistry, P block elements, D block elements. See, compartmentalization is good, not bad. As I say, don't take it on the face value that I say. What I am trying to say here is, even though it is presented you in a chapter wise, you should have the ability to link one chapter to the other, understand the commonality, understand the link, and that's what teacher has to do. So in the textbook is presented that way, but when the tutor or teacher teaches you, they should link and they should ask you to link, giving some intriguing questions. This is how you study. If you are simply studying separately for organic exam, separately for inorganic exam, physical exam, you will never improve. Zero. You understand, no? I don't like these kids who are studying until they enter the exam hall. Why are you doing? Whatever you have not studied these many days, will you do it in the last minute? Why are you doing? You will make yourself tension at the time by doing that. You don't do. Why? Correct? So if you practice yourself like that, you will be the winners. We don't practice. Today you will write one exam, tomorrow one more exam, further again you will study. Day after tomorrow one more exam, again you will study. How long, how many times you will study same thing? Syllabus is same for all the exam. Then why so many times you are studying? There is a problem with you. You have to approach the problem differently. Then you don't need to worry. Right? Okay. This I have been telling to every student, nobody believes me. Okay. But I believe in this concept, I studied like that only. It works for me. I taught like that to my kids, so it worked for them. So I believe in that. So I don't believe in sending kids to private school. I send kids to government school. Not because I believe government school. I believe in myself. He goes to school just to enjoy. I am not expecting anything from the school. Given that teachers are asked to do everything, go pick up the chapel, come and deliver to the kids, go pick up the books, come and deliver. How much work a teacher will do? Everything teacher has to do. Every government teacher is treated like a slave. Not right. They are given the job of teaching, they should do that properly first. For that, whatever time required, you have to give. You should not ask them, go here to head office, go here to the Chennai for transfer, come this, that. What? People get tired. You are making a teacher tired, how he or she will teach you? They cannot teach. You should respect them. We means our system. Otherwise, you will not get output. If I ask you go here, there, then come and do work also, will you do? Same problem to teacher also, right? Yeah. That's why I like this job, because here is so much freedom. Whatever I want, I can do. I would have not been happy in a school or some other college or something. This is very difficult, because college every day come and punch in the morning, correct? No, evening again punch and go. What is this? In between, what you are doing only matters. Punching not matter. For you, it is needed, because you will tell at home that I am going to college, then you will go to watching the cricket thing and get into trouble, right? Don't do those things. Right, now let's come back, because it's too much of story.
SwayamPrabha. Digital India. Educated India.